All right, so good morning everybody. We were talking about MITRE DEF3ND and we discussed about digital objects, digital artifacts and how digital objects and artifacts kind of connect the offensive model of MITRE, which is the MITRE attack model, and the defensive model of MITRE, which is the MITRE DEF3ND model. So, as usual, before we do that, let us look at how we are doing in our understanding of things. So, get your phone out, menti.com, the code is 15286361. So, when we consider a digital object as digital artifact, okay. Yeah, so we discussed this last time, the digital object, anything, an URL, an IP address, a file, all of those things can be digital objects, but we consider it as digital artifact if that particular object is either being created during an attack or used by an attacker or used as artifact for detection by the defenders or as forensic reasons. So, then it is a digital artifact. So, almost actually everybody got that correct. So, let us look at so what is the role of a red team in an organization? Is it to carry out VAPT? Is it to test the countermeasures or defend the organization against cyber attacks? Okay, so red team is actually meant to test the countermeasures, the controls that you have put in. So, VAPT is vulnerability assessment and penetration testing. In vulnerability assessment, we actually use some kind of a tool to scan the network, to scan the applications, to scan the existing configurations, and we figure out if some known vulnerability CVE is actually there in the system. So, known vulnerability is found through vulnerability assessment, usually done using tool like Nessus, but penetration testing is more active process of trying to breach the various applications, various network and operating system, firmware, etc., but it does not think in terms of the countermeasures. So, red team's job is to actually work against the blue team, and they are aware of the countermeasures and they try to evade the countermeasures to show to the blue team that their countermeasures are not effective enough, right. So, red team is different from the VAPT. Now, we have three true or false questions. Tactics, techniques, and one statement about technique implementing tactics. Okay, so this was also discussed in the last class that tactics are basically about what and techniques are how, and that is why techniques implement tactics, right, because so if you are saying that techniques implement tactics, but at the same time you are saying that techniques is what, and tactics is how is that possible, right? What see how is the method of implementation for something which is what, right? So, techniques and tactics are techniques are what's, hows and tactics are what's. Now, we discussed about the CAR, and we showed you car.mitre.org website as well. So, what is CAR? Yeah, so it's a cyber analytics repository, and we showed you how to get there, and you can see what different ways in which you can detect various techniques. Cyber analytics repository is a set of tools, scripts, various rules that you can implement inside your network intrusion detection system or host intrusion detection system to actually detect various techniques, whether that somebody is trying to use those techniques in your system, like somebody is trying to do something in the to persist something and to create execution in the system and so on and so forth, right, or trying to do lateral movement or trying to do command and control. What are the tools or scripts, etc., available? So, that's cyber analytics repository or CAR, and you can find those in car.mitre.org. So, we also showed you the CAPEC website. So, CAPEC is what? Yeah, so common attack pattern enumeration and classification, right. So, that is the capec.mitre.org. You have, that is where the various common attack patterns you can find. It has been catalogued. So, if we go there, like so this is the CAPEC website, and here you can find various attack patterns. Like, for example, they have been numbered. So, mechanisms of attack. So, if you now look at these, like engage in deceptive interaction, abuse existing functionality, manipulate data structures, manipulate system resources. Now, if you go into one of these, software integrity attack, then if you go to this malicious software update. So, this is malicious automated software update via redirection or routing of SIM cards, malicious automated software update via spoofing. So, these are the various common patterns, attack patterns, and each of them has description. You have mapping friendly versions, and then you have the corresponding weakness, common weakness that is being used, and so on and so forth. So, so you can actually get this whole catalog or knowledge base of various common attack pattern enumeration. So, so you can actually refer to this as and when needed, when you are doing some defensive mechanism or trying to analyze a particular attack. Okay, so coming back to the DEF3ND framework. So, we actually discussed that digital artifacts basically is the connection between attack and defend models. So, for example, suppose there is a exploitation for client execution or exploitation for privilege escalation. So, you have either you have an exploitation of a remote service or process injection. Now, the artifact in which you will find something some indicator that you have a process injection, that is somebody has injected some code inside a process, running process, so that it does not have to run as a separate, the mischief or the malicious code is not running as a separate process, but somebody injected code into a running process or through a DLL injection, or there is a remote service that is being exploited by, let us say, exploiting a buffer overflow and then or some kind of a code execution, then the indicator will be there inside a code segment of a process, right. So, you know that every process has virtual memory associated with a process, and the virtual memory is divided into these various segments, and code segment is where the code is loaded in the memory, right. So, process code segment. So, now if I know that that is the artifact, that is the digital artifact which I should inspect in order to know that something like that is happening, then inside the defend, as we go into defend, we have not gone into the defend yet, but in defend there would be a particular technique called process code segment verification. So, that basically look at the processes code segment, the integrity of the code segment, whether the code segment is what it is supposed to be versus what the code segment is currently being loaded. If there is a variation, you know that something, one of these might have happened, right. So, this is the way digital artifacts connects the offensive model with the defensive model. Defensive model will obviously, certain part of defensive model will not depend on an artifact being generated from the attack model, because for example, hardening, right. Hardening is when you actually proactively do things to change the processes or change the configuration of software operating system, or you change the various methods, like for example, you change it into two-factor authentication instead of single-factor authentication. So, these are hardening process, right. So, hardening process happens before you look for attacks. After you have hardened a system and you have deployed the system, you are hoping that since your system is hardened, lot of the attacks can be stopped. Like for example, if you have two-factor authentication, the possibility of somebody using an user credentials to access your system, unauthorized user using an authorized user's credential is lowered, the probability is lowered that that would happen. So, hardening reduces the probability of a particular attack, but a hardening does not eliminate the possibility of an attack. Therefore, we have to also look for detecting whether an attack is happening, and if detection is a very important part, and as you will see that in all cybersecurity frameworks, like if you look at NIST framework, in NIST framework we have various functions: identify, protect, detect, right. So, and then you have respond and recover, right. So, there are 5 different functions in the first version of NIST framework. NIST 2.0 came out like day before yesterday, officially came out. So, it has 6 functions instead of 5, but the point I am trying to make is that no matter how much hardening you do, no matter how many different controls you put, you have to always assume that there will be clever attackers who will actually circumvent those possibilities, and therefore, there will be attacks in your system, and therefore, we have to be able to detect when attack is happening, and then accordingly we have to either deceive the attacker, or we have to isolate the part of the system which has been attacked or compromised already, or we have to actually evict the attacker from the system. So, that those are the different tactics, top level tactics of MITRE DEF3ND framework. So, now we go into the MITRE DEF3ND framework. So, MITRE DEF3ND framework has this 5 top level tactics. So, harden, detect, isolate, deceive and evict. So, in case of attack we had 14, 12 plus 2, 14 different tactics. Here we have 5 different top level tactics, easier to remember, but these, if you are ever going to be a cybersecurity personnel inside an organization, these are the things that you would certainly do, right. So, these are things that from which you will start. So, you have to think what I am supposed to do, and these are things that will come to your mind. So, now we will go into this top level tactics to this, they are now in a different framework, they are have this different sub tactics which are application hardening, credential hardening, message hardening and platform hardening. So, when we say we are hardening our system, we are basically saying that we are trying to make the configurations of our systems in such a way, so that the possibility of somebody breaching the system is reduced, right. So, and then they say, okay, so if I want to harden, what are the things that I can harden, right. So, the application hardening, how to make your application such that even if the application has certain vulnerabilities such as buffer overflow vulnerability, we can still obviously we can still stop an attacker from exploiting it, right. Credential hardening is when we are trying to make sure that the credential of users, legitimate users, cannot be misused by an unauthorized user or unauthorized personnel, because we probably will require two-factor authentication. We may need a digital certificate pinned to a particular user's device. So, this kind of things will allow us to stop an unauthorized users to just steal somebody's password and use it to enter our system. Message hardening. So, message in a system may have many meaning. For example, when we have an API call, you can call that as a message, right. We are basically sending a message from the client to a service, right. So, API call could be a message, it could be an HTTPS, an HTTP request could be considered a message, or any kind of two different processes, they might be using a message passing protocol, application level message passing protocol. Those kind of things are, or you can have a socket connection. So, you can have a messaging between two processes which are establishing a TCP/IP TCP socket or UDP socket, this kind of messages. So, these messages can be intercepted, they can be replayed, they could be actually modified and then sent to the service on as intercepted in the middle of its journey, and that could create various cyber attack possibilities. So, but if we do message authentication, if we do message encryption, then it becomes harder for a man in the middle attack, somebody intercepting the message and then changing some of the parameters or changing the message. It becomes difficult if you add authentication and encryption on the messages, right. So, message hardening is one such thing. Platform hardening is very important because many times we actually make mistakes in configuring things. We actually keep many ports open, we keep operating system unpatched, we keep the applications unpatched, we keep the firmware unpatched, we often do not configure things like for example, some encryption for your important files, we may not configure them. Various things we may make mistakes about, which would eventually cost us an attack. So, therefore, platform hardening is also an important part of hardening. Now, if you go into the attack website, defend website, defend.mitre.org, you can then go into the further details of all of these things. For example, here I am just giving an example of application hardening, right. So, application hardening may have multiple different techniques by which you harden an application. So, what does that mean? For example, pointer authentication. So, those of you who have taken CS 628 would remember how a buffer overflow attack happens, right. So, when a buffer overflow attack happens, so you have a program which has a stack, program stack, where there is a buffer, array variable, right. So, it's a character array. So, that character array, if you write on that character array a very large sequence of characters, it will overflow the space allocated for it, and it will start writing over other elements on the stack, and then go beyond the stack to write on the memory locations beyond that stack segment of that particular function. And in this process, if you do it right, then you will eventually write the return pointer, right, the return. So, when you make a function call on the stack, the return pointer, say in the C main function, you are calling a function f. When it goes to the function f, it creates a stack segment, right, and then it creates a, it pushes a element on the program stack where all its variables are stored. But when it finishes, the function f finishes, it returns, it has to know where to come back. So, it has to save the return pointer, place where it has to return. So, if during buffer overflow, if you rewrite that address, then when you finish this function, you will go to a different place, not the place where you are supposed to go. So, this is what buffer overflow does. Now, there are various ways to stop this. For example, there is something called DEP. This is the data execution prevention. So, if you turn on data execution prevention, then you cannot have execution from that point. So, but if you actually authenticate the pointer, that if you store the pointer in another place to compare. So, when you finish the function call, you get the return pointer, but you do not trust it. So, you actually check it against a stored value of the function pointer, then you will get you are basically authenticating that pointer, or that pointer may be signed by a particular can be hashed and signed, right. In that case, you can check whether that stored value of the pointer matches the pointer you are seeing at the end of the function call. So, that is what is pointer authentication. So, configuration hardening. So, many complex applications has many configuration that you can do. So, they are usually a configuration file. So, if you have ever compiled a very large program, usually it also generates a configuration file which you have to change, right, in which you have to write a specific configuration information. It could be a JSON format, it could be a specific format. So, the program, as it starts up, it reads the configuration file to know what configuration it should set up for the particular run of the program. Now, usually for testing and for novice users, there are certain configurations which are left default, right. Now, if you run your program, run your application with default configuration, maybe there are certain vulnerabilities. So, you have to change the configuration to change that possibility, right. So, that is what is application configuration hardening. Date code elimination. So, many programs, very large, especially very large programs, they might have lot of files and lot of code segments which are in the system, in the source code directory, which are no longer in use, but in your make file you still compile them and link them, right. Now an attacker may find that and say that, okay, so this part of the code, even though it is not useful for them, I can use it, I can redirect, using a buffer overflow or something, I can redirect to that point of the program, and then it can execute from there and it will do something that is useful for me. So having dead code inside your application, compile into your application, is bad idea, because it can be misused against you. So eliminating any kind of dead code. Now for a very large, 1 million line, 2 million line application, the source code application, finding the dead code is non-trivial, right? Because those of you who actually have taken theory of computation should appreciate that finding dead code is actually a undecidable problem, right? Because it's a reachability problem, whether the code ever reaches that point, right? Whether the application ever reaches that point. So dead code elimination is non-trivial, but the application developers, they might be able to have a better way to find the dead code and remove it from the compiled code. Exception handler pointer validation. So so one of the way attackers may use buffer overflow against you, especially if you have turned on DEP, the data execution prevention, is to use the exception handlers, right, to make you jump to the exception handler and then writing a malicious code in the exception code. So that exception handler pointer validation. So you actually have to know what are your exception handler pointers from the beginning, so that somebody has inserted extra code for as an exception pointer should be detected. So these are all runtime methods. Process segment execution prevention, that is what the DEP is all about. And then segment address offset randomization. So this is ASLR, address randomization, so that the attacker cannot use the buffer overflow easily by calculating where the return pointer address is and things like that. Stack frame canary validation. So many times we put a canary so that if there is a buffer overflow, it will also rewrite the canary, and then by checking the canary, I can detect whether there is a buffer overflow. So buffer overflow, all these things that we just talked about is about assumption that application code that is used in today's world cannot be guaranteed to be free of mistakes like buffer overflow. So buffer overflow mistakes are very, very common, and therefore as a cybersecurity defender, I want to make sure my runtime validation against possible exploitation of buffer overflow are all configured. So I want to do address space layout randomization or ASLR. I want to have DEP or data execution prevention. I want to be able to detect, have canary. These are all runtime system checks against buffer overflow while exploitation. So I want to have all this. So this is what application hardening is all about, right? Credential hardening is another hardening. Now, when we are giving you these examples, this is not the exhaustive list of possible hardening, right? So the hardening just I showed are possible. These are all possible hardenings, but tomorrow somebody might add 3 more application hardening techniques into the knowledge base. So that's why it's a living knowledge base at MITRE. Similarly, credential hardening, we are talking about 4 different techniques. So certificate pinning. right. So you may want to actually, so one of the, suppose you want to go to your bank, right, and it's an online SBI bank, and your local DNS resolver, right. So when you type in SBI onlinesbi.com, what happens? Your browser, if it already has recently been to SBI, then it will actually have the IP address, corresponding IP address. So it will send the HTTP request to the right IP address. But if it doesn't, then it will go to the DNS resolver, right. Now local DNS resolver might be, so we actually, when you configure, or if you go and look in your computer and do an IP config or IF config, you see a DNS address, right. So I think it's 131, 172, something 131 is the DNS address. So that's our local DNS resolver, right. So the local DNS resolver will actually show you the IP address for SBI, right. Now suppose Soumitra here decides to take your money, right. You don't manage the DNS, do you? Yeah, so somebody in the DNS, in the CC decides that they will change the DNS translation of SBI to their malicious server that they have put up. So every time somebody new types in SBI, it goes to that address, and he makes a nice SBI web page which looks like SBI, right. You will not see the difference. Now only thing that will save you is a SBI certificate, right. Whenever we go to SBI, it sends us digital certificate to our browser saying that proof, as a proof that it is SBI, because this certificate is signed by some certificate authority which tells us, and which our browser can check against the known certification authority signatures that this is SBI, right. Now suppose Soumitra also manages to get a certificate from another organization, a rogue organization, and it actually happened. CDAC, which is a government organization, gave digital certificate for both Yahoo and Google domain in 2012 to some random people, right. So then for a while, the Google.com and Yahoo.com was translated to some random IP addresses within India, right. So let's say, and this has happened. So certificate authority people may have gone rogue and they give a certificate of SBI. So now Soumitra can prove to your browser that he is SBI. This will go on for a while. It may not go on for a long time, because eventually SBI will get complaints and they will do something. But for a while it can go on, and then in that time you type in your username, password and all that stuff. Now thankfully SBI also requires OTP, right. So he won't be able to get your money, right, because the bank, he will get your username and password. He can actually do a social engineering to get your OTP also, but then Soumitra has to do other work also at CC, so he doesn't have that much time, right. But this can happen, right. I mean, I'm not saying Soumitra will do it, but somebody can do it, for not necessarily for bank, but some other place where there is no OTP, right. So there is no second factor authentication, then this can be easily done. So what you do is you pin your browser can pin the certificate of SBI, so that no other certificate of SBI, no other thing that claiming to be certificate of SBI will be recognized by your browser, right. So that is certificate pinning, right. So you can actually save yourself by doing certificate pinning. So another thing that we do in our hub is that for important applications where we want only a certain number of people to even see that such an application exists, such a web application exists, we actually ask them to pin a certificate in their browser of their own. So, unless they present that certificate to our application does not even show up, right. So, that kind of certification pinning. Multi-factor authentication, all of you understand why it is important. OTP, one-time password, as I said that this is very important. Strong password policy, of course, is something that you can enforce. For example, when somebody is changing their password, if they do not do certain combination like one capital, at least one small, one capital, at least one letter, at least one number, at least one special character, total length at least 14, 12, whatever, that is strong password policy, you can enforce it, right. So, that way you can do credential hardening. So, these are some of the examples of techniques for credential hardening. So, message hardening, as I said, that we always use messaging in various forms like API calls, HTTP requests. So, we can do socket level messaging. All this can be intercepted in the middle, like HTTP is one of the biggest problem, because HTTP is not secured, it is not encrypted, it is not authenticated, right. So, when I am doing an HTTP communication with a web application, all the thing I am doing is interceptable and changeable, right, because there is no authentication, right. So, this is one of the other problem is that many times you will find people use self-signed certificates. They think that if I have to do HTTPS, I can self-sign a certificate and use HTTPS. But the problem with self-signed certificate is that suppose I run an application which basically sends a self-signed certificate to your browser. So, what does your browser do? In 10 years ago, browsers wouldn't care, certificate is certificate, right. Now, Chrome, Firefox, all of them will complain. They will say, this is not safe, do you want to still go to that website, because we cannot guarantee safety, because they cannot recognize that certificate is signatory, because the signature is done by you, like by IIT, somebody inside IIT or something. So, why is the browser complaining? Because the browser is saying to you that I do not recognize it, right. So, so now somebody in the middle, so my application and your browser, right, somebody intercept the messaging between us, right, and present another certificate to you as me. Your browser does not know that from the certificate that I was giving, right, because both certificates are unrecognizable to the browser. So, browser will say that if you are going to accept the certificate from Sandeep, why not certificate that is now presented as Sandeep's domain as somebody else. So, browser will accept it, right, and then that person is now having will get your username, password, whatever you type in, you will get it, right. So, therefore, certificate has to be recognizable by the browser, right. So, self-signed certificates usually, that is why is not acceptable by current browsers, so like Chrome, etc. So, messaging has to be authenticated, and authentication means digital signature, right. How do you know that this is Sandeep's digital signature? I have to also give you my certificate, which is authenticated by a known certificate authority, so that the browser can check that, okay, whatever Sandeep is presenting as digital certificate is actually a valid digital certificate. His public key is valid public key of Sandeep, right. Otherwise, anybody can claim that this is Sandeep's public key. And message encryption, so that nobody can intercept in the middle and change the message. Transfer agent authentication. So, when we have, for example, in mail system, we have this mail transfer agents, right. So, these mail transfer agents have to be authenticated, like Is it this IP address that from which this domain can send email, right? So this is the SFP check, right? So message hardening is one of the other things to reduce the possibility of attack. And platform hardening has all these things like encrypting your disk, for example, or part of your disk where you have critical files, etc. When you load a driver, right? So one of the major attack, now it has reduced quite a bit, is a driver. You get a driver for your printer or your various devices, and that driver itself has is actually malicious. So now you check the signature on the driver. So nowadays the Microsoft, if the driver is from Microsoft will hash the driver binary, then it will sign it with with its private key, right? And then the Microsoft's public key. How do you know Microsoft's public key? Because Microsoft has pinned the Microsoft certificate inside the operating system. So you can retrieve Microsoft's public key from there, use that to check whether the driver is really signed by Microsoft. Then you know that the driver has been written by Microsoft, compiled by Microsoft, and while transferred from from Microsoft to you, it has not been tampered with. It has not been its integrity has not been compromised. So driver load integrity checking, then boot integrity, right? When your machine boots, right? If somebody has changed the boot code to do various malicious things, then it will start completely compromising your operating system. So usually we also do the check the integrity of the boot code. How do we check the integrity of the boot code? Again, we have to check against a signature. Now, who signed this? This is signed by a private key that has been put by Microsoft or whoever is responsible for the boot code firmware, right? So this is usually based on the trusted platform module, right? So some of the major keys in a system nowadays, in today's system, like in high-end phones, for example, they have a TPM or trusted platform module. So certain keys are actually put into the trusted platform module. So and any kind of signature that has to be done using that key, you don't bring the key and put it on your application level or in the memory. You actually send the content, the hash or whatever you want to get signed. You send it inside the TPM. TPM will give you the signed document. So you will never see, nobody inside your platform will ever actually see the key in memory, right? So that's how you save the integrity of the key. So these are platform hardening. So when you are as a defender of your organization, you will tell that all the assets, all the devices you have inside your organization, including servers, including desktops, engineering workstations, or any other device, you would like to get them hardened, at the credential hardening level, or at the operating system hardening level, or all the applications that are put on them, hardening them and all that stuff. So you have done all that. Now you say, okay, so I have done all this, so I can sleep better. Actually you cannot, because that does not guarantee that you will not get attacked. So now you have to think in terms of, if I get attacked, how do I detect, right? So that's where the detect tactics and its various sub tactics will come in, right. So, what are the various detect tactics, right, techniques. So, file analysis. So, this is somewhere you know that antivirus tools do file analysis. They actually check for signatures inside files, binary or any PDF or Office documents or JPEG documents or anything that you download, zip files and so on. They try to find signatures of malware. In more advanced file analysis would require machine learning, right. So, machine learning based analysis for existence of malicious code by extracting features from the file and so on. So, you do file analysis, you can also do you know, file hash and use that against a list of hashes you know as malicious, right. So, you can do that as well. Identifier analysis. So, identifier analysis, so it might have multiple different meaning. For example, when you have an URL or IP address, you may actually check it against a list of malicious URLs or list of malicious IP addresses. There are machine learning techniques by which you can detect whether a particular URL is suspicious. So, this is identifier analysis. The other part of identifier analysis is like, let us say you have a browser and you click on a link, right, and the link goes to some site that actually looks like a known website, but there is a slight difference. An A there is replaced by an alpha, right. These are called homoglyphs, right. So, you have a URL that looks almost like the legitimate URL, but it actually has some slight difference. So, it is a different going to a different IP address. So, this is one way of phishing and one way of you know, sending it to a malicious website by using what is called homoglyphs. So, detecting homoglyphs that you are now as a human you may actually be very conscious, and you can every time you go to a click on a URL you check one by one, letter by letter, am I falling victim to a homoglyph attack or not? Nobody does that, right. So, system has to do it. System has to look for homoglyphs before redirecting you to a particular website. It should check for possibility of homoglyphs. So, this is part of identifier analysis. Message analysis is when you have messages of various kinds, including email messages. You know, you may have to do analysis before you deliver it to the final destination, like a user, to see whether there are malicious content in the message, or in case of API calls, you want to see whether it has a sign of a malicious API call, things like that. Network traffic analysis is very important. What kind of network, and detecting various signs of intrusion, various signs of anomaly, those kind of things. Monitoring the platform, that is the host monitoring, right. So, not only monitor for malicious files, but you also look for signs like sudden change in performance, CPU, sudden strain on CPU, sudden strain on memory usage. You may want to also look at various other things in the platform, like whether some system files or privileged files are being changed, or you may want to look at whether a particular binary is being replaced by a different binary. This kind of stuff is in the platform monitoring or host intrusion detection. Process analysis is when a running process is being checked for possibility of process injection, DLL injection, or you know, going through going through an exploit like buffer overflow exploit. Now, nowadays also the insider attack is very important, like the insiders may do things which are harmful for the system. So, user behavioral analytics, there are lots of tools nowadays. They analyze what the users of your organization are doing in terms of their access to various resources, their login times, their usage of external resources like websites, FTP, SSH, all these things, and they try to find suspicious activities of users. So these are currently the list of different sub tactics of detect tactic, right, which has much more elaboration in the system in the MITRE DEF3ND.mitre.org website. We will go through this in the talk that I am planning to record this weekend. So I already discussed all these things in some way, but I think a little more discussion we have to do on each of these. Then we will talk about the isolate and deceive and decoy and the evict, right, and then we will finish defend, right. So I want you to understand, if you were to defend your organization or defend your sub network wherever you are, what are the things that you are supposed to think about. So how to think about what all you need to do in terms of defending your organization's network. Then we will go into the risk, how to do risk assessment of the organization with respect to cyber threats. Okay, all right.